service. Hey. That's right, my friends. I'm back again with yet another math video. Woohoo! And look at we got ourselves
Zeke the zebra.
He's back, and dude, you look totally different, man. What's different about you? You didn't get a haircut. I don't know, your ears look like about the same length as last time. Still got your tail. Look at you're still carrying that mud around. Do you take that mud with you everywhere?
Hey, I know.
Dude, why do you have blue eyes, man? I don't remember you having blue eyes before. Oh, really? This is too hilarious. Really? You got contacts? You think you're going to be able to see better so the lions don't eat you up? Dude, okay, that is too funny. Hey, you know what? Yeah, okay, you keep your blue eyes. I don't know. I see disaster in your near future, if you know what I mean. Hey, my friends, well, welcome fourth graders to, yes, another math video. It's another review math video. It is chapter 5. We've been looking at all different kinds of things related to factors and multiples and blah, 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 right? All that fun stuff that we do. So we're going to go ahead and get started with number 9. And you know, we're going to have to shrink you there, Zeke. You're a little too big for us here, if you don't mind. Shrink. I love making that sound. Shrinky. Yeah! Oh my goodness, he's so tiny. Mini zebra. Okay, we'll make you larger. Whoa! Did you see his face was like all blue there for a second? Ah! Okay.
Mr. Wara, you really need to focus.
I know. Okay, I'm sorry. I'm just in a really silly mood today. Come on, just stay still, buddy. Yes, don't worry. We're going to leave you right there. Okay, you can have your mud and everything there. Okay.
Well, at least that's what he tells us it is.
Anyway, we have number 9. It says the number of pieces of art at a museum is shown in the table. And we can see there's art. We have the type of art. And we have the number of pieces. Oil paintings. We have 30 of them, and photographs. Ooh, we have 24. That's right, photographs. That's a kind of art as well. And then we have sketches, and there's 21. So part A says, the museum is hosting a show for July that features the oil paintings by different artists. All artists show the same number of paintings, and each will show more than one painting. How many artists could be featured in the show? Ooh, no, I feel a headache coming on. No, you know what? It seems kind of hard when you first read it, but I bet if we go back to the problem and reread it, it's going to help us. So here's our museum. It's hosting, and hosting just is kind of like the person who's going to be hosting the show for July that features the oil paintings. Oil paintings by different artists. Okay. Now it says all artists show the same number of paintings. So notice it right away, and not that I want to make a mess here, we're really not looking at photographs. Ooh, sorry. And nor are we looking at sketches. Sorry. Hey, we had to get you kind of out of our mind because we want to focus. That's right. Right there at oil paintings with a pretty arrow. And so it says that all artists are going to show the same number of paintings, and each will show more than one painting. How many artists could be featured in the show? Ooh, this is really kind of tricky. But when I think about it, it says that right here that the oil paintings, there are 30. So let's just say, for example, we could say, and it says, okay, the key point here too is that each will show more than one. Okay, so we couldn't have, let's just say, we couldn't have 30 artists, right? If we had 30 artists, okay, and each one showed one painting, right? Then that would equal 30, because 1 times 30,
in case you didn't know.
I know you fourth graders are smart, you do. So, but that's not what the problem says. It has to be more. Keyword more than. Okay, so could we do, let's say each artist did 2. Well, 2 paintings for each artist times, I don't know, so many artists has to equal 30 art pieces altogether. Oh, wait. Okay. All right, Z, good for you. Boy, this zebra's pretty smart. Yeah.
I'm really surprised.
Okay, so yes, it is 15. I don't know how you knew that, buddy. My goodness, it's not like you do like math out on the savannah or anything, you know? Anyway, so I'm going to do it kind of reverse here because look at this is the multiplication fact. We could have 15 artists, right? Each showing 2 paintings, that equals 30. But we could also have just the reverse, 2 artists showing 15 paintings. Ooh, this is so confusing. But we know we can't have one. So we could have 2. We could have 2 artists showing 15. See, now you see what we're doing? We're actually finding the factors of 30. That's one way to look at it because 2 times 15, oops, I almost forgot my 1, equals 30. 3, I know. 30 is divisible by 3, if you remember from a previous lesson. So we could do 3 times 10, which I know you guys are like screaming. I know it. So we could actually have 3 artists, right, showing 10 oil paintings each. Will 4 go into 30? No. But 5, yes, 30 is divisible by 5, and 5 times 6 is also equal to 30. So that means we could also have 5 artists, and they could each be showing 6 oil paintings. And of course, that means it could be 6 too, because 6 artists with 5 paintings. Won't be 7, won't be 8. And you know, this is just like what we were doing before when we were looking at our pairs, and 5 and 6 gives us 30. So we're really just looking for the other pair. Yeah, and then we're going to look for that final pair for 2, which is going to come up here. Well, 3 times 10 was 30, and then 2 times 15. So how many artists could be featured in the show? I think we'd answer it this way. It would be 2, 3, 5, 6, 10, or 15. And that's my final answer. Cool, time to move on to part B. Oh my goodness, this is easy. Oh, and there you are. How'd you do that? He just slipped on down the page. Very cool. Let me guess, you brought your mud with you, right? Oh, there's your mud. Oh, okay. Let's go ahead and take a look at what part B says. It says the museum wants to display all the art pieces in a row. Each row has the same number of pieces and the same type of pieces. How many pieces could be in each row? Explain how you found your answer. Yes, let me catch my breath. Okay, Well, I'm telling you, my friends, it seems a lot harder than it really is. So I think the way I'm going to solve this problem is there's some key words in the language here. For example, it says that they want to display all of them. This is key. Art pieces in rows. For some students, this is kind of a hard thing to just kind of imagine. So let's just go ahead and draw it out. Okay, can you picture that? Here's our art pieces. They're in a row. And we would have some here down here too. But it says each row has the same number of pieces and the same type of pieces. Then it says how many pieces could be in each row. So the key thing that I see here is this right here. Each row has to have the same number of pieces. And to me, this is really important. The fact that they sneak this in here, same type of pieces, means that I have to look at each one of them. I have to look at the oil paintings. I have to look at the photographs. And finally, the sketches.
And Mr. Wara, that's really messy.
It kind of is. Okay, but let's just know that that's the 3. We have to look at all of these. We had 30, 24, and 21. So I think I would probably want to look for common factors. And so I'm going to just kind of find all the factors of each one like we did before, I believe, kind of like in a previous lesson. We had 21, 24, and then we had 30. So now I'm looking at factors. Well, we know that they all have the factor of 1. Of course, 2 won't work for 21. 2 will work for 24 because 2 times 12 and then 2 times 15 will give you 30. That's cool. So 2 won't work for 21. So we can't use that one because it says same number of pieces and the same type of pieces. So with the same number of pieces, we wouldn't be able to do a row of like 2 and then show that. Here you could have 2 rows of 12 and 2 rows of 15. 3 happens to be divisible. Yeah, 21 is divisible by 3. 24 is divisible by 3 works because 3 times 7 is 21. 3 times 8 is 24. And then, of course, 3 times 10 is 30. 4 works here, but does not work for the other 2. 5 only works for 30. 6 works for 30. Also works for 24, won't work for 21. Then we get to 7, 8. 8 won't work here. 8 works here. And as you can see now, we're getting up to the point where it's like, okay, now I'm looking at my pairs, like 6 and 5, 3 and 10. Okay, 10's still not going to work, 2. That's it, my friends. So we have 1 as a possibility. We have 3 as a possibility. Now I need to get some of my notes because it says explain how you found your answer. So I'm going to say it's just 1 or 3, okay? And the reason why I say it's 1 or 3 is because I listed all of the factors of 21, 24, and 30. Okay, I listed them all over here. The only common factors they have is 1 and 3. I'm going to put and 3. I almost put or and or. Okay, cool, let's move down. Oh my goodness, we're moving to another problem. Yes. It says Charles was skip counting at the math club meeting. He started to count by 8s. He said 8, 16, 24, 32, 40, and 48. What number will he say next? Well, I remember doing a lot of skip counting. This is kind of nice. 8, 16, 24, 32, 40, and 48. And we need to know the next one. Okay. Oh, was that pretty awesome or what? Woohoo, Mr. Ward did some magic and I didn't even try. We're just going to leave it there because actually, you know what? I'm kind of glad it's a little bit bigger because I need it to be bigger. So when you're skip counting, you're adding 8 each time, right? But since we're kind of moving up into 4th grade, you guys aren't babies anymore. So it's like saying, okay, what's 8 times 2? It's 16. And then 8 times 3, you can see the pattern here. 24. 8 times 4, 32. 8 times 5, 40. Last time I checked. And then 8 times 6 is 48. So rather than trying to keep counting, it'd be easier just to say, okay, I'm just going to take 8 times 7. Which we all know is 56, right? Because you know your times table. Oh, I wrote on your tail. So sorry. So sorry. Not really. Oh, no, I really am. I just was kidding. Okay. All right. Number 11. Jill wrote the number 40. If her rule is, look at this, add 7. What is the 4th number in Jill's pattern? I love it. How can you check your answer? Awesome. So she says she wrote down the number 40. Let's write it down. We put 40. If her rule is add 7, what is the 4th number in Jill's pattern? Well, that's the first number. If we were to add another 7, that would be 47. We add another 7. That looks like it's going to be 54. We have to add one more 7. Look, that's going to be 61. That happens to be the 4th number in her pattern. But it says, how can you check your answer? Well, first I'm going to put 61 as the answer. How can I check? I would say that we could maybe subtract 7 each time. That's about the only thing I can think of. Because if you did subtract 7, that would bring you back to 54. Subtract another 7, that'd be the way of checking our answers. So I'm going to say 61. I could subtract 7, okay, because those addings is just the reverse. Subtract 7 from 61, then 54, then 47. There you go. And get, that's a G. Woo! Forgot the hook. And get 40, which brings me back to the number I wanted. Cool. All right, man. There's Zeke. Time to move on to the next page. See you later, dude. Page master. Oh, dude, you just like dominating the page. Look at you. And there's that mud. No, I'm just kidding. Is that your shadow? It's just always sunny where you go? How's those blue eye contacts hanging in there? Really? Well, maybe because it's not natural for you to have contacts, dude. Come on, Zeke. Really? Okay. Yeah. Okay, I get it. Good point. I can't argue with that one there. My goodness, Zeke. All right. We do need to make you small, though, again, because you are really just huge. You went from huge to small to huge again. It's just really freaking me out. It says here that for numbers 12A through 12E, select true or false for each statement. Okay, so I have a 50-50 chance of getting these correct. Cool. It says the number 36 is a multiple of 9. So when we say a multiple of 9, that means that we're taking and we're skip counting. So this is really hard for not even just fourth graders.
My fifth graders, too.
It's a challenge because they keep getting confused what a real multiple is. We don't say that 9 is a multiple of 36 because when you say of 36, you're saying I'm going to start with 36 and then I'm going to start following multiples of 36, but that's not what it says here. Always look for these three, little, not even I would say number, but these three pieces together. Multiple of 9. If they say multiple of 9, you're skip counting by 9s. Here, multiple of 9. Multiple of 9. Ooh, this is different. Factor of 9. Factor of 9. Okay, so really important that you focus in on that. So yes, the number 36 is a multiple of 9. See, it's almost like we're going, okay, of 9. All right, I know. I'm really...
Mr. Wara, you really need to, I don't know, maybe give up coffee altogether?
I could try to cut back, maybe. Okay. So anyways, yes, that's true. I say true, true and blue. Okay. The number 3 is a multiple of 9. See? See what they're trying to do to you here? They're trying to mess with you here. They're trying to say 3 is a multiple of 9? No, we're starting with 9, remember? How is 3 ever going to be a multiple of 9? Never. And it's so easy to make that mistake. 9 is a multiple of 3, but 3 is not a multiple of 9. See? Pretty sneaky. Because just think of your skip counting. So false. Falso. You are not the chosen one. Okay, the number 54 is a multiple of 9. Yes, if we were to continue with our pattern, it'd be 9 times 5, which is 45. 9 times 6, which is 54. Yes, sir. I'll take it. True do 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 do. The number 3 is a factor of 9. So now we're not talking about multiples. Now we're talking about factors. Something completely different. With factor, I always keep going back to, that's right, factor times a factor equals product. Why is that so important? Because if you're saying that number 3 is a factor of 9, here's your of 9 right here. Your 9 is 3 a factor of 9. Yes, 3 times 3 is 9. True. Absolutely. Give that one in there. The number 27 is a factor of 9. See if we had that same thing again, equals, and it says a factor, number 27 is a factor of 9. So I'm still putting 9 here because we have that little part of 9. Is 27 a factor of 9? No. 9 is a factor of 27. So if we hit it like this and we had 27, sure, 9 times 3 is 27. So 9 is a factor of 27. 3 is a factor of 27, but not the other way around. That doesn't even make sense. False. And that is my final answer. Yes, it is. Let's move on down. Here we go. Yeah, Zeke, I see you. You're such a nice guy. Okay, 13. What multiple of 7 is also a factor of 7? Since it's telling us multiple of 7, why don't we just do some multiples here? Skip counting, right? 7 times 2, 7 times 3. Well, actually, even the first one, 7 times 1. That's how you get 7. 7 times... Oh, look at, I just talked myself into the right answer. Did you see that? Yeah. What multiple of 7 is also a factor of 7? Yeah. Look at, something times something is going to be a factor of 7. What could you do? Yeah, there's only 2. 7's a prime number. So the only 2 factors of 7 is 1 and 7. So 7, because it's a multiple of 7, because it's the first number when we start skip counting, and it's also a factor of 7 when you multiply it with 1. Oh, that was a very tricky question. Tricky, tricky. Oh my goodness, if they put that on the test, I don't want you guys to fall for that one. Woo! All right. Am I still moving down? Yeah. Number 14. Manny makes dinner using 1 box of pasta and 1 jar of sauce. If pasta is sold in packages of 6 boxes and sauce is sold in packages of 3 jars, what is the least number, okay, that just seems really important here, of dinners that Manny can make without any supplies left over? Oh boy. How many dinners? Well, just think about it. It may seem hard, but I'm going to do this the old fashioned way. See, just think about it. If you were like really struggling, you could just say, well, if, when he makes his dinner, right, he's using one box of pasta to one jar of sauce. So it's like a 1-to-1 ratio there. The problem is that he has 6 boxes of pasta because that's just how it's sold. That happens. And the sauce is sold in packages of 3. So when you think about it, you just skip counting. So you have 6 boxes, and then if you were to buy another package, it would end up being 6 more boxes in that package. See what we're doing? We're just getting multiples. 6 times 3 is 18. 6 times 4 is 24. So then over here, we're going to have our package of jars. Well, you buy one package, you're going to get 3 jars of sauce. You're going to do it again. 3. I almost put 9 because I went 3 times 3. 3 times 2. Then 3 times 3, 3 times 4 equals 12. So now that you can kind of see that we're just kind of like finding multiples of each, we can go back to the problem and say, what is the least number of dinners that Manny can make without supplies left over? So you can see here, if he has 1 box of pasta and 1 jar of sauce, you can see that he's going to take 1 from each one of those. So if you took 1 jar to make a dinner, he's going to take 1 from each. It's going to leave him with 5. See that pattern? Right there, that gives him 1 dinner. He still has 2 jars. Okay? He wants the least amount they can make without supplies left over. So you start to see the pattern here. What's really going to happen here is that you're going to end up being able to have 6 dinners because you're going to use each one of those packages, and then that's going to make that go to 0. Now, this is eventually going to make there's no jars left. We're going to have 0 here, see? But you're still going to have 3 over here. But just to be clear here, I'm doing another 3 here because there's another 3, but this is really another 3 jars. This is another 3 jars. This is another 3 jars. I was doing multiples. And so with only there being 3 jars over here, and you still have 3 boxes of pasta here, because we use 3, it comes in a package of 3, another package of 3, but that's going to end up being total. You can see that we're going to end up with 6 dinners. The first 3 boxes got used up, all the 3 jars of the sauce. Then another 3 jars of the sauce. So what we were really looking at is something, and I don't know if we've even done this. I don't remember if I taught this yet, but it's a least common multiple is what we were looking for. And that's how it solves the problem, because 6 is the least common multiple, so you can make 6 dinners. 15 says Serena has several packages of raisins. Each package contains 3 boxes of raisins. Okay, she has several packages of raisins. Each package contains 3 boxes of raisins. Which could be the number of boxes of raisins Serena has?
Mark all that apply.
So if we have 3 boxes of raisins in one package, we're going to have another package that's going to have another 3, meaning we're going to end up with 6 total boxes of raisins. And you can see we're just finding multiples at this point. 3 times 4, 3 times 5, 3 times 6. You get the picture. 21. And then another 3 by is 24. We got to go all the way up here because we have 32. I just saw that answer. 30, 33. So all we did was find multiples of 3. Which could be the number of boxes of raisins Serena has. We don't know how many packages she bought. She didn't buy just 1 package because there's a 9 here. Could she have bought 2 packages? Absolutely. A, you are in the running. You are a final contestant on the answers to problem number 15. 18? Yeah, that showed up on my list. 18 works. That would mean she'd have 6 packages of raisins. Oh my goodness. 6 packages of raisins. 18 boxes. 23 never appeared on my list. Sorry. How about 27? Yes. I'll go with 27 because 27 is here, and 3 times 9 is 27. That means I have 9 packages, 3 boxes of raisins. You get it. 27. And 32? No, sorry. You're not in the running. It's just A, B, and D. Last one. Well, you do a good job just staying out of the way here. That tail is just really pushing it, buddy. Anyway, choose the words that make the sentence true. The number 7 is prime or composite. Oh, yes, we talked about that in a previous lesson. Prime has exactly 2 factors, and a composite number has 3 or more. So, is 7 prime? Yes, because you can only do 1 times 7. There are no other factors that you can multiply to get 7. Impossible. Because it has, I already kind of told you, it has exactly 2 factors. There you go. Oh, man. That's awesome. Hey, what? Huh? Um, okay. Yeah. What you All right. All right. I'll go to the next page. Okay.
Yeah, apparently Zeke wants to talk in private.
I don't know what this is all about. Okay. I don't know. Yeah, I suppose. But I've never done that before. Really?
A question and answer?
What are you? Like you're somewhere. Hey, wait a second. What happened to your blue eyes anyway? They're gone. Yeah. I don't blame the herd. What do they call you guys? I forget what you're called again, right? You're called a herd? No, you have another name. Oh, that's right. That is what it is. Okay. So, yeah, I don't know. I'll ask the fourth graders. We'll see. I don't know. We'll see. Okay. It's not like, it's not like you're super, super famous. I mean,
No offense, Zebra.
I mean, you've only been in this video that I'm aware of. Maybe you were in another video. Okay, I'll ask the fourth graders. Hey, if they like the video and I get a lot of likes, that probably means that they want the interview with you where they get to ask you questions and you're going to answer them.
My goodness, like he's famous because he's from he's like on the safari. Let's go on the safari.
Yeah, okay. Now can I do... Thank you. All right, thank you, sound crew. Get that music going, my friends. This is kind of throwing off my rhythm. This is normally where the music comes in. Yeah, hey, hey, it is time to say adios, my friends. But there's a third video coming up, and I never leave forever. No, we'll be back, my friends. But
live long and prosper.